Welcome to Moon Day 2020 at the Frontiers of Flight Museum.
We're Cynthia
and Dietrich Whisennand, NASA, JPL, Caltech, Solar System Ambassadors. And we're here in the new Spaceflight Gallery in front of the museum's Omniglobe, which is currently projecting the surface of Mars.
Speaking of Mars, we're here today to talk about the Perseverance Rover. First, we're going to show you a NASA video about building the rover and its various parts.
Again, this is Dr. Cynthia Whisennand and Dr. Dietrich Whisennand, both Solar System Ambassadors for many years. This is the Earth and the Moon. It's what it looks like from Mars. The closest we get to Mars is 35 million miles, and the farthest is 250 million miles. To make the shortest trip, the launch is currently scheduled for early on July 30th, 2020, and the landing on Mars on February 18th, 2021. Perseverance will make a trip of 309 million miles over 7 months to get to Mars. It'll land on Mars much like its predecessor, Curiosity, except for its terrain-relative navigation landing system. This gives it the ability to avoid hazards in a landing path without human intervention. It will basically use the same type of guided entry with a heat shield, a supersonic parachute, and the sky crane maneuver to help land at a gentle 2 miles per hour. The rover is almost identical in size to the Curiosity rover, but it's heavier and has improved instruments.
There are 4 science goals. Science Goal 1, determine whether life ever arose on Mars. Science Goal 2, characterize the climate of Mars. Science Goal 3, characterize the geology of Mars. Science Goal 4, prepare for human exploration.
So, there are 7 main instruments on the spacecraft. These make Perseverance into a robotic geologist. The rover usually communicates with Earth through one of the several relay satellites orbiting Mars. However, it can send data directly to the Deep Space Network if needed. Each of the main instruments have the ability to call home to Earth individually. Now we're going to talk in detail about some of these instruments. The camera, the Mastcam Z, that's the main eye of the rover. It can take HD video, panoramic color, and 3D images of the Martian surface, and also features in the atmosphere. Next is SHERLOC, with its sidekick Watson, of course. The scanning habitable environments with Raman and luminescence for organic chemicals. It uses spectrometers, lasers, and a camera to search for organics and minerals. It has a red laser to ablate surfaces. That means it vaporizes part of the sample and analyzes the vapors. Raman is the green laser that measures the vibration of molecules. And it has a second eye, Watson, the wide-angle topographic sensor for operations and engineering. Next, there's Pixel, the planetary instrument for X-ray lithochemistry. Using its X-ray fluorescence spectrometer, it can see features as small as a grain of salt. Its main job is to measure the chemical makeup of rocks on a very fine scale. Like the space station, it also has a robotic arm. A 5-jointed robotic arm almost 7 feet long. And it's used in combination with a turret to pick up and analyze geological samples. Now on the body is Rimfax from Norway. This is not an acronym. Rimfax is the horse in Norse mythology that faithfully brings the night. It has ground-penetrating radar with vertical resolution 3 to 12 inches thick, a penetration depth greater than 30 feet, depending on the materials. They tested it on glaciers and found it successful. The interval of measurement is every 4 inches along the rover's track. Next, there's MOXIE, the Mars Oxygen In Situ Resource Utilization Experiment. Don't you love the acronyms? The ultimate goal is to produce oxygen from the Martian atmosphere for propellant and breathing. It's the size of a car battery. Of course, a future one would have to be 100 times bigger. Carbon dioxide makes up 96% of the Martian atmosphere, but oxygen on Mars is only a trace of 0.13%. Of course, oxygen on Earth is 21%. MOXIE inhales carbon dioxide from the Martian atmosphere and exhales oxygen and carbon monoxide. Homemade liquid oxygen could supply more than a quarter of the propellant needed for the exploration of Mars and for the trip home. Next, there's MEDA, also from Spain, the Mars Environmental Dynamics Analyzer. Its weather instruments include wind speed and direction, pressure, temperature, relative humidity, radiation, and the amount and size of dust particles. In the belly of the beast are 2 identical computers that run the entire rover. Now, legs and wheels are its mobility subsystem. The rover is able to drive 200 meters on its own at a speed of between 100 and 120 meters per hour. That's slow for a car, but fast for a rover. Each of the 6 wheels has a separate drive motor, and its front and back pair of wheels have steering motors as well. The suspension system allows the rover to drive over an obstacle the size of the wheel itself, over 4 feet. Let's kick the tires here. When Curiosity drove on the soft surface of Mars, the not-so-soft, hard rocks ripped the surface of the wheels apart, and the zigzag pattern's sharp corners created hot spots, which caused faster wear. So they redesigned the wheels for Perseverance, making them slightly larger and using a tougher material with more rounded tread. And then something new, microphones. These are used while we're landing, while you're driving around and collecting samples. The sound of Mars. Now, the power source for all of this is something that we've used many times in space flight. The power system is the heart of the rover. An MMRTG, a multi-mission radioisotope thermoelectric generator. It uses plutonium-238 to generate power, rain or shine, for over 14 years. And the waste heat circulates in a fluid system to keep the body warm. Sound familiar? Remember, the temperature on Mars ranges from minus 64 Fahrenheit to minus 200 Fahrenheit. And then for sample handling, it has a caching system. It will take over 20 samples into the rover. A camera will be able to see inside the sample tubes before they're sealed and left on the surface of Mars for a future sample return mission. This is one of the hardest parts of the rover to build because it's brand new. Now, this is the landing site of the Perseverance compared with some of the other landing sites that we've had on Mars. So it's a new territory. The landing site is a Jezero crater. It's about 30 miles wide. And they chose this spot for a landing site because it was a river delta. Scientists are looking for rocks and minerals that could have only formed in water. And one of the last new things is the Ingenuity helicopter. This 4-pound solar-powered helicopter drone has 2 cameras, one black and white and one color. Its main purpose is to see if we can really fly on Mars. It'll be tested for flight stability and for the potential to scout the best driving route for the rover. It's expected to fly up to 5 times during the 30 days testing, and it will fly for not more than 3 minutes a day. Again, we're just trying to make sure it'll work. We don't know. And we'll show you a video about that in just a moment. So here's where we got some of our information there, NASA and JPL at the top. Now, here's a video about the ground testing of this groundbreaking helicopter. So this is going to be for the helicopter on Mars. It's stored underneath the rover, and it's lowered when they're ready to fly it. Once it's out there, though, there's no going back. Here's what it should look like flying on the red planet. Thanks for your attention, and watch the thrilling expedition as it unfolds on NASA TV.